This video is on the carbonyl compounds, which is 3.4.5 on the spec. It's part of Unit 4, and as always I'm starting with the basics. So carbonyls have the functional group C double bond O. This is polar because the oxygen atom is more electronegative than the carbon atom. This polarity therefore allows nucleophiles to attack the partially positive carbon atom in nucleophilic addition reactions. And just so you know, this symbol here symbolises the partial positive. If it was a negative sign, it would be partially negative. So right now we need to know about the aldehydes and the ketones. So the functional group of the aldehydes is RCHO. For ketones it's RCOR. In terms of numbering, it's not needed for the aldehydes as these always take carbon 1, whereas for ketones we always have to write the number of the position of the ketone, and this has priority, so we give it the smallest number possible. Finally, in terms of naming, we add the suffix al for aldehydes and on for ketones, and that's the way you can remember it. Put emphasis on the words, the syllables. So I've put two examples here. One, I've got the ethanol, and in the second I've got the butan-2-one. What I want you to just look at for the butan-2-one is, if you go from the left hand side, you would have got butan-3-one. This would have been incorrect for this, because if you start from the right hand side, you get butan-2-one, where the number is the smallest, therefore it's gained priority, which is correct. So moving on, what do we need to know about the solubility of the carbonyls? Well, this depends on the chain lengths. So long chains are insoluble and short chains are soluble, and when we're referring to solubility, this basically means a molecule's ability to dissolve in solution, but in A2 terms it's to form hydrogen bonds with water molecules. And the reason that long chains are insoluble is because the chain gets in the way of the hydrogen bonds, but that's going a bit further than what you really need to know. And finally then, the nucleophilic addition reactions that I was talking about before. Well, an example of this is adding HCN. This forms a hydroxynitrile. However, we don't use HCN directly. The reason for this is because it's toxic, so instead we use sodium cyanide or potassium cyanide in addition to sulfuric acid, where the cyanide then comes from the sodium cyanide or potassium cyanide, and the hydrogen comes from the sulfuric acid. The conditions for this reaction is done at room temperature, and I've done the mechanism for you, so you can just observe that, and I'm sure you'll be able to understand it. So that's all you need to know though for the basics of the carbonyl compounds. There is a lot more, so be prepared.